All right, ladies and gentlemen, we are going to be using a formula. In this case, it's the one we've been using. So we had been looking for what happens for the event of A or B. But this time we want to know what happens if A and B, and there's going to be potential of overlap here. And this is worked out already for us. We used some algebra. Remember, we actually had the probability of A or B is equal to the probability of A plus the probability of B minus the probability of A and B. But what happens when we need a formula that we don't have for the idea of probability of A and B? Well, we can actually use algebra to solve the equation or the formula given to find the probability of A and B is the same thing as the probability of A plus the probability of B minus the probability of A or B. If you have any trouble looking through on how I solve this, remember if we're subtracting something, we add it to the other side, and all that does is move it and create zero pairs on the other. So nothing really changes. When I when I added the probability of A and B from the right side to the left, that gave us the probability of A or B plus the probability of A and B is the same thing as the probability of A plus the probability of B. But I'm not done. I'm trying to isolate the probability of A and B. So I subtracted the OR probability from each side, creating a zero pair on the left and moving it over to the right, perfectly legal. So that gave us the probability of A and B is equal to the probability of A plus the probability of B minus the probability of A or B. And the reason we wanted to isolate that is it's asking what is the probability that a randomly selected senior is both a varsity athlete and the honor roll. So we're trying to find the probability of A and B, but we only had the formula for the probability of A or B. Now we've got the other. We could actually do the same thing. If we're trying to find out what the probability of A is, and we're given the percents for everything else, we can substitute, move around. I could have substituted in all the numbers and everything else to begin with and moved around and would have looked a little bit more familiar, but I want you to see that no matter what our formula looks like, we can always isolate what we're trying to first and then substitute, or we could substitute and then work on isolating. It's really up to you. We can use formulas however we need to. We just use algebraic rules to do so. All right, moving on and getting this done. The probability of A is, what color was that? Blue. Okay, the probability of A is 74 seniors are varsity athletes. The event A is senior is a varsity athlete, so 74. Now, there were a total of 200 students that were surveyed. And then we had, there we go, we had 51 seniors out of 200 who were on the honor roll. And here, we had A or B is, I didn't use either one. Okay, so we're going to use green for that. Now we got to subtract off the 113 who's, 113 students are either varsity or on honor roll. We've got that statement right here. We had our original 74 that I said right here, and we had that 51 right here. So now I have all my statements, and so now I can find the probability of A and B by just simply combining. What I get is 74 plus 51 minus 113 is 12. Let's use fuchsia. 12 out of 200. That can be simplified, but we can go directly into, no, we better simplify. 3 out of 50 or 0.06, which is about 6%. So again, fraction, decimal, or percent form all tell us the same thing. 3 out of every 50 seniors asked should be a varsity athlete and an honor roll. I had to look up to see what we were doing again, which is the same thing as 0.06 or 6%. Should be both varsity players and honor roll.